Alright, good morning. Today we're continuing chapter 5. We started a little bit of chapter 5 yesterday. Hopefully, first section will be completed today. Let's quickly go over what an angle means, and what kind of angles we have, and what measure of an angle means. An angle is actually a rotated ray. You take a ray, rotate it, and form kind of two rays meeting at the corner. That's what we call an angle. So you start with a ray, rotate it, and stop. You create a second ray when you stop. So that whole thing, two rays connected at a vertex, is called angle. Okay? Well, we don't just randomly start in the middle of the page and rotate angles. We start rotating angles on positive x-axis. So your initial side in standard position is on positive x-axis. And then you rotate usually in counterclockwise to the left, and create a positive angle. If you rotate clockwise direction underneath x-axis, then we create a negative measure of the angle. So you can rotate clockwise, but it's not traditional. We always rotate to the left. So the standard position means one side of the angle is locked on the x-axis, initial side actually. Alright, we learned about measure of angles to describe how wide these two rays are far apart from each other. We put a numerical measurement to angle, and it all started with the entire turn. If this initial ray makes a full turn around x and y axis, and we call it 360. It's like the entire pizza pie. And then according to slice size of each pizza, we take partial amounts. Like this is 1/8 of a whole pizza is 45, because 1/8 of 360 is 45. If you have a quarter pizza, this looks like quarter, right? So the second one looks like the quarter pizza. So it is 90 degree if you rotate counterclockwise, but I see that this is rotated counterclockwise from this arrow direction. So I take off 90 from 360. The leftover pizza is 3/4. 3/4 pizza is 270. It's negative though, because it's clockwise direction. This is look like one slice out of 12, because 1/4 is split into 3 pieces. 1/4 is 90, and if you separate 3 pieces 3 ways, it's 30 each. This was 90 plus 30. And then we had some of the angles come with a name, such as this quarter angle, quarter pizza slice. When you complete this into pizza again, I always give the example of a pizza. Just imagine you have a whole pizza here. This covers about a quarter of it, that angle. So if it's a quarter, it's 90 degree, we know, but that's a special angle denoted by this corner. It's called right angle. So when I call right angle something, it's 90 degree. There's two ways, two opposite ways, rays. One on positive x-axis, the other one is on negative x-axis, is half pizza size. It's 180 degrees. And acute angle is any angle less than 90 but positive. This is again, there's a typo here. Obtuse angle is anything more than 90 but less than 180. Okay. Alright, and yesterday we mentioned about degree, minute, and second relations. I mean, if you need to split an angle into lower than 1 degree, you need to go with minutes. If minutes not enough, you want to split more into pizza slices, you go with seconds. Again, in 1 degree there are 60 minutes, in 1 minute there are 60 seconds. So in other words, in 1 degree you have 3,600 seconds. This is the second symbol. Okay, and 1 degree is 60 minutes. each minute is 1 minute is 60 seconds. But when you do opposite relations, 1 minute is 1 over 60 degrees. 1 second is 1 over 3600 degrees. And 1 second is again 1 over 60 minutes. Okay? And we did make these conversions. I didn't like the way I solved this one yesterday, so I'm going to repeat this one. Okay? We are supposed to convert a degree to minute and seconds. So let's take a look at those relations. 1 degree is 60 minutes. 1 degree is 3600 seconds. So these two is what you need. 1 degree is 60 minutes and 1 degree is also 3600 seconds. So what I have here is you have minus 31 whole degrees, but any partial degree must be made into minute and second. So I'm okay with the degree part. Only thing we need to fix is this partial degree needs to change to minute and seconds. So for this, we take this additional part and turn this into minute first. Okay? So I take 0.58 degrees and multiply by what? 60. We need to clean this now. It's no longer degree when you multiply by 60. And we get, what was this? 340, 34. We get 34, no. 0.8, right? 34.8 minutes. But, so, right now we have minus 31 degree, and then 34.8 minute. But as you said, we don't like partial amounts. Now we have a partial minute. We need to convert it into seconds. I'm okay with the 34 minute. It's whole minute. But you have a partial minute. Let's turn that partial minute into seconds. So that's 0.8 minute needs to be changed into seconds. So all you need to do is multiply that 0.8 by another 60 to turn it into seconds. So it's going to make 48 seconds. So that made 48 seconds. So it's minus 31 degree, 34 minutes, and 48 seconds is the answer. Okay? So you start from the bigger pieces and split off into smaller and smaller. Yesterday we directly split off into seconds and then converted back to minutes. That wasn't ideal. So this is our final answer. Degree to minute, if there is still something left out, partially from minute to seconds. Alright. Now we are going to describe something very important. There is more than one way to measure angles. It's not only degrees. So you're used to degree, maybe you love degree measurement, but unfortunately in calculus, in your next class, every computation, derivatives integration is done by radian measure. So in college algebra, in this course and later math courses, radian measure is essential. So we need to learn this well, radian. Okay, so what is radian measure? In usual, the entire circle consists of 360 slices or 360 degrees, right? So the total was 360. Now we are going with a different kind of measurement sense now. Now, radian measure is, 1 degree is 1 out of 360 slices. You slice it up, but radian is different. 1 radian is a lot bigger than 1 slice of pizza. It's a lot bigger. You just start here. This is start. You travel on this path, on this circle, until you travel one amount of radius. So you first take a ruler and measure this. Measure this, maybe 10 feet. And then you start your travel on this circle. And when you hit 10 feet radius distance, you stop. Form your ray there. Go to origin and form your ray. This angle is exactly 1 radian measure. Okay? So, for example, if you have a smaller size circle or bigger size circle, the measure is still the same. Look. Look, I start here. Well, this is about how much I need to move. I move on this, and I need to go about that distance. This is what 1 radian measure is on this little circle. Right? These two distances, this distance and this distance. Because this is a tiny circle, you move tiny on the first small circle. But this one is, look at this one. This one is a large circle. I need to move this distance on the second circle. So I move this far this time and stop. And look at the result. My second ray is on top of the first one, green and blue matches. So radian measure, you have a feeling that, oh, in radian measure, big radius give us bigger angles. No, it's the same size angle. Look, these two angles, green and blue angles, match. So in radian measure, you're independent from radius as well. It looks like we are moving the radius size here, but since small circle, you go faster, rotate, but in big circles, you rotate smaller, less, because it's a long way to turn. Okay? So in any case, in radian measure, we are independent from the radius again. You move according to radius size, but the resulting angle is the same no matter how small or how large your circle is. Just move along as long as the radius, whatever the radius measurement, it's 1 radian. Okay? So, here's a question. Again, theta, the angle, is measured by how far you move, how far moved on circle, ratio size of radius. So you measure the size of radius 10, you move 10, the radian measure is 1. 10 over 10 is 1. Okay, here is one example. How far did we move? This is start. This is end. How far did you guys move? 1 R. I see 2 R movement, right? 2 R movements. Whatever R is, if you like, take 15. So you moved 15 and another 15. What is the total movement you made in this angle to make this rotation, wideness? 30 or 2R. You moved 30 or 2R, 2 times 15. But what is the initial radius size? 15 or R. So if you like, you put here 15. But it's not necessary. R is 15. But anyways, what's happening here is they are canceling. So it doesn't matter what R size you choose, 100 or 15, they are canceling. It doesn't matter. So what is the radian measure of this theta? This openness? 2. So this is 2 radians. You put RID, not this anymore. If you put this, you're wrong. It's not 2 slices. 2 degrees is about this small. 2 degrees is really tiny little. If you put here this, you're wrong. Okay? Don't put it in a circle. It's just put this. Alright? Okay, I have another question. Let's see if you can compute this. Alright, here is my initial side of my my ray. This is the one end of the angle. Now I'm going to take this ray and rotate it how much? Not a quarter, not half, not 3/4, but full turn. So there is an angle, initial and terminal sides match. You made full turn. So this is the path you followed. You started here, rotated, 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 and came back here. In other words, they notate this like that with this arrow. Okay, I want you to measure this in radian. I know if I ask this theta, you will say theta is 360 degrees. You're correct, 100%. But what is this in radian? I want you to come up with this number in radian. You have already answered 2 pi. How did you come up with that answer? How did you get that pi? How do you know 180 is pi? You just do. It makes sense. We've been taught that way. 180 is pi. 90 is pi over 2. Yes, you're already ahead of the schedule. You already know those things. But have you ever wondered why 180 is pi? With this description, it's because of this. Theta is found by path moved over radius, right? Path moved, how far you traveled versus radius, right? Well, isn't the path you moved the entire circumference? So it's the circumference of the circle. The entire one, not the partial, not halfway. Entire circumference. Don't you guys know how to compute circumference of a circle from geometry classes? I don't know if you've taken or not. What is the circumference of a circle? What is this? How do you compute that? Is it pi r squared? Pi r squared is area. Circumference is? Anyone? You're close. It has pi, but 2 pi r. 2 pi r. Did you know that? 2 pi r. Two pi r. Okay, circumference is 2 pi r. Area is pi r squared. Yeah, there is an alternative formula. Circumference is actually pi times r if r is the diameter. But here we're dealing with radius, okay? Yeah. Yes, you're right. If you're computing through the diameter, it's just pi r. But we are taking radius on a small piece. Okay, this is 2 pi r then. And there is an r matching on the bottom. And look what's happening. That's why, again, now you learn why the entire turn is 2 pi in radian. Good. So please note this, and we won't be doing this again. The whole turn, 360-degree turn, is 2 pi radian. Okay? And once you get the whole pizza pie, you can get the half or quarter pizzas, right? So what is the half pizza? Half turn. It's pi. How about quarter? Pi over 2, because it's half of a half pizza. It's a quarter pizza. 2 pi divided by 4 is pi over 2. What if you have 3/4? Technically, it's 3/4 of 2 pi, right? Look, this is whole pizza. whole pizza, and you are taking 3 out of 4 slices. 1 slice, 2 slices, 3 slices out of 4. But once these two cancel, it reduces to 3 pi over 2. Yes, 3 pi over 2. So know these common angles in radian measures. Again, this is 3 pi over 2, pi over 2, pi, and we already built this one, 2 pi. Again, this is the demonstration how we ended up with 2 pi. And by the way, most people treat this pi as a variable. It's like pi is like x or y, 2x, 2y. No, pi is actually a fixed number. It's like, imagine it like 3 feet long. It's a little bit more than 3 feet long, 3.14, etc. It keeps going. It's a never-ending number, but it's never more than 315. It's about 3 and some change. So 3 feet long times 2, you have about 6 feet long circle here. So this angle, this distance is about 6 and some change, this entire circle. Okay? So this is a number, just like you put 360 is a number, 2 pi is a number as well, 6.28, but it's a never-ending number. That's why we use pi. Okay, so these are some common angles we need to keep in mind. We keep going. We are if we need to, how we change from degree to radian and radian to degree. There are 2 basic formulas you need to use. If you need to change from degree to radian, you need to multiply degree measure by pi over 180. If you want to do backwards, change from radian to degree, you put 180 on the top, pi on the bottom. For example, how do I change minus 330 into radian? You take minus 330, multiply by what? Pi over 180, perfect. It's degree to radian, degree to radian, degree to radian, pi over 180 comes, and you need to simplify for sure. So I first cancel zeros, is 33 over 180. Divide both sides by 10, divide by 10. And then, can I divide 33 and 18 by another number? What? There's a common divisor of both. 3. So it's minus 11 and 6. Are there any more numbers common between 11 and 6? No. So this was minus 11 pi over 6. Now how do we type in this? Minus 11. I want to try a couple things. Let's first write minus 11 over 6. And then can I put the pi next to it? This works. You can separate pi kinda away from the numbers. Or you can put this pi right on the top next to 11 in the numerator. Okay? It will take both ways. You can put this minus pi, you cancel it, go to the top, you can put it next to 11 as well. Alright, next we are gonna do a backwards change. You have a radian measure, we are going back to degrees, radian to degrees. So this time, what do we need to multiply this with? 180 over pi, right? And automatically you see pi's canceling. So if you confuse which way is that, I mean 180 on the top or pi on the bottom or pi on the top, 180 on the bottom, this is the trick. Pi should be on the opposite side. Okay? So this guy already have pi on the top, so my pi should be on the bottom. Okay? So they can cancel. Alright, and what else is canceling here? 3 goes into 180 how many times? 18 and 3, 660. Alright, and then we have 2, minus 2 left. Minus 2 times 60 is negative 100, negative 120 degrees. And when you're typing in your answer, let's see if it's already have a degree. You don't have to worry, but sometimes you need to make your own degree symbol. Look, this one doesn't have a degree symbol already built in the box. I believe if you type in only 120, it's gonna say wrong. Let me see. You see, it says wrong, although this was perfectly fine answer, right? What did I miss? I didn't put the degree symbol. Where do we do this? We do this, yep, with this. Now we're good. Okay, so be careful, because if you don't put nothing, it assumes it in radian. So you're putting here minus 120 radians if you don't put that little circle. Okay, now we're gonna talk about coterminal angles. What do I mean by this? Look, when I put down two angles like this, you may say they are the same. Look, I'm putting an angle here. I'm putting same direction, same tooth. You may say they are the same, right? They are looking the same, you're right. But if I put this, are they the same now? Look, what does this arrow do? It says how much initial side rotated to make this angle. It's a little bit, it's like a quarter, no, it's about 1/8 of a slice turn, right? But now look what I'm doing. I'm not stopping. I took a full turn and came back and made a little bit one more piece of slice. Now, can you claim these two angles are the same? No, because this side maybe made several turns. Look, you can make one turn, two turns, and some change. Okay. So just two angles look alike doesn't mean they are the same. You may have more turns involved with it. So these are called coterminal angles. Different. They are not the same angles, but since they ended up on the same final, look at the final position of the ray, they are the same. So they terminated at the same location. So we call them co-terminated or terminal. Okay? So we're just gonna do exercise about them, and they always differ by 360. They always differ by one turn, or maybe several turns. Sometimes twice the turn, sometimes 3 times the turn. So you add multiple 360s, or sometimes you take back, subtract. This is subtraction, negative. You subtract 360 to go back, because does it always have to be going counterclockwise direction? No, sometimes they go backwards, clockwise direction, to go to same terminal position. Okay, so you just need to read the title statement and see what kind of coterminal angle we are supposed to construct. They say find a positive coterminal angle and also a negative coterminal angle, but they will look like just like 307 degrees. Alright, you don't have to sketch, but sketching helps me. I want to sketch that angle first, right here, tiny little bit. Okay, here is 360 degree angle. So it's a little bit, this is 270. If I turn it 3/4, this is 270. It's a little bit more than 270. It's about this way. This is 307. Because this is 270, so a little bit more change. This is 307. 307. Okay. Now I need to create same angle. I just need to turn more. Okay, I just need to turn more. I'm just going to add one more turn to this. I need to get a full turn so I can go to the same terminal destination. So what is the positive angle you can make? Positive coterminal angle to 307 is? This is already 307 turn. You are turning one more and stopping at the same location. So it is 307 plus what? 360. Well, can you make 2 full turns and stop? Yeah, I can create many positive angles. I can do 2, I can do 3 turns, 4 turns, 5 turns, but they just want 1, and the simplest one is make just 1 full turn and you get 1 times 360 add 307, it's 667. Alright, they want negative coterminal to 307. All you need to do is do backwards turn. Turn -1 means clockwise, make full turn. You get, if you go backwards, turn this way, you stop here, and you end up with this openness within the negative sense. It's -53. So 307 minus 1360 is -53. Well, can you do 2 backwards turn and 3, 4? Yeah, you can go -1000s, 2000s if you wish. That's not necessary. They say the lowest magnitude, so don't do 2 turns. Lowest is 360 plus this 667. And lowest magnitude negative is -53. Any questions about coterminal ones? You just rotate more and more. Okay, we are making a same example, this time with radians. What's different in radians? So when you already have an angle here, pi over 6. This is already pi over 6. That means 30 degrees. 30 degrees is pi over 6. And you are adding 1 full turn to it. So somebody added 1 full turn, but full turn is 2 pi. So you're adding 2 pi to pi over 6. What is 2 pi to pi over 6? You need to add these numbers by setting common denominators. To set common denominators, you multiply first one by 6, and that's 12 pi over 6 plus pi over 6, and add 1 pi to 12 pi, you have 13 pi's. 13 pi over 6, that's how they come up with this number. Look, if you add, this how many turns is this? This is 2 turns. If you make 2 turns, that's 2 times 2 pi, 4 pi. If you add 4 pi to pi over 6, you get 25 pi over 6. Oh, do we always need to go counterclockwise? No, if you go clockwise from pi over 6, look, I'm moving clockwise, 1 turn from clockwise. So it's negative turn, 1 turn. And 1 turn means -2 pi. And you subtract pi over 6 minus -2 pi. By setting common denominators again, you need to multiply by 6. 12 minus 1 is -11 pi. Okay? In our question, they want you to find out an angle between 0 and 360, between 0 and full turn, but that's gonna be coterminal to 41 pi over 6. How big is 41 pi over 6? This is a big angle, right? Isn't it big amount? 41 pi over 6. If you like, divide 41 by 6. What is 41 by 6? It's about 6.8333. Okay? So it's about 6.8 pi. If 2 pi is 1 turn, This angle is, look, this is about 6 point, is that 6.8? Yes, 6.8 pi means if 2 pi is 1 turn, this is about 3 turns. So we are talking about an angle. It turned 3 times around x-axis, and you have a little bit change. It's not just 3 turns. This is turned more, some change. So it's 3 turns plus some change. So it's kind of something like this. So it's something like this. It turned 3 times and stopped here. Anyways, this is too big. We need to take it back. It turned 3 times. We need to take it back to an angle between 0 and 2 pi. Again, this is the situation what happened here. You had an angle. Alright? It turned once, twice, 3 times. I know 6 pi is, look, 2 pi, 4 pi, 6 pi, and 83. 6.83. Somewhere here. Because 1 pi is this long. Pi is half circle. This is 83 pi. 0.83 is about somewhere here. So this is what happened. One, two, three. This is 41 pi over 6. You need to now take this back and make this only something between 0 and 2 pi. So I need to take this 1 back, 2 back, 3 back, and bring it here. So 3 back means 3 times 2 pi. So I need to subtract 6 pi from this guy to take it back. Because it has excess turns. We don't want these so many turns. We want to take and trim the excess back turns and get it only whatever is the left out, okay? So when I subtract this, I need to set the common denominator. What is left? 41 pi over 6 minus 36 pi over 6. What is 41 take away 36? 5 pi over 6. Okay? So the result is 5 pi over 6 is coterminal to this. Alright, let me repeat another idea. This is trial error. First, do you have a feeling this is a big angle? Big positive angle? Look, 41 over 6 is big number. So I first take it back 1 turn. Take 1 turn back because this cycled so many times. So many cycles this made. I'm gonna take it back 1 turn. What happens if you take it 1 turn? You're taking it 2 pi off, right? Multiply both sides by 6. And 41 minus 12 is 29. Now question is it between 0 and 2 pi? Is this thing between 0 and 2 pi? No, this is still big. It's more than 2 pi. So what I do is I take 29 pi over 6 and take 1 more turn back because it has more cycles in this. So I take 1 more turn, and this time this is 12 over 6, multiply both sides by 6. 12 take away 29 is 17 pi over 6. Is it between 0 and 2 pi now? Is this thing? 17 over 6 is almost 3. No, this is still too big. So I take one more turn back. So this is 17 pi over 6. One more turn. This is 12 over 6. 17 minus 12 is 5 pi over 6. We got the same answer. Right? 5 pi over 6, 5 pi over 6. How did I do this? I take one turn back at a time until I get something between 0 and 2 pi. But this may take a while if you do this one by one. My recommendation again, estimate 41 over 6 in decimals. It was 6.8, and every 2 is 1 turn. So I sense this is 3 turns. I took 3 turns back in one shot. Okay? Alright? Let's see if it understands pi. Yeah, you can type in pi if you like, but I like the symbol better. Alright, now what we are gonna do is next is how do we compute an arc length of a piece of a circle. Arc length means length of a piece of a circle. This is a piece. We are measuring this. How do you measure this length? If you know the angle and if you know the R. So two things should be given to you. Radius of the circle must be given, because the bigger the radius, the longer this piece will be. And theta should be given to you. The bigger the angle, the bigger the piece is again. So it's just multiplication of R and theta. However, everything is computed in radians, not degrees. Don't use the degrees. Okay? So if somebody asks you a piece of circle that is corresponding to 150 degree angle, this is 150. They are asking for this piece. All you need to do is write this formula, R times theta, and multiply them. What is the R? Radius 15. The theta is 150, and this is gonna be 2250 unit length, whatever the length is. Am I right? Yeah, I should be right. 2250 yards. Wow, because radius is in yards. Well, doesn't make sense. You have only 15 yard radius. Can you get 2000 yards? It says incorrect, but I already knew it was incorrect. Can you get 2000 length for such a small circle? 15 yard is not that much. So what did I do wrong? I thought the formula was this. I'm supposed to multiply these two, right? So what did I do wrong? Yeah, told you. Theta should be is in radians for this computation. This is not in radians. So you guys need to change 150 into radians, and I bet you're gonna multiply this with something on the top and bottom so it can make radians. So what am I supposed to multiply with it? Pi over. Good. So we divide by 10 first, and then we divide by 3. 5 pi over 6. Is that so? This should have been 5 pi over 6 then. This is modified to 15 times 5 pi over 6. Oh, look at this. There's another cancellation by 3. Right? So we have 25 pi over 2. Or isn't that 12.5 when you divide 25 by 2? It's not necessary. Oh, let's see. They want us to get the decimal up to nearest tenth, yeah, we need to divide and multiply by 314. So please do compute this in your calculator by taking pi as many digits you like, but round it into the nearest 10. So 25 pi over 2 is first digit, right? So I'm going to round this up into 3. 26 is 30. 29.3 is the, no, 39. Okay, nearest 10th is first digit. Any questions? Are you good, Ashley? So it makes sense. 33 yards is a lot better. Oh yeah, part 1 says exact length, so it's 25 pi over 2. Thanks. Thank you. Now we need the approximation in part 2, which is 39 over 3. Was it 39.3? Good. I want the exact one as well. Alright. Okay, we're going to make one application to real life situation. Latitude, longitudes actually use degrees, angles. Okay, so let's investigate that. Now, what is a latitude? The Earth is split into circles. You see there are circles going around the Earth. Those parallel circles, horizontal circles kinda, it's called longitude. It says longitude. So these circles are called longitude. Okay, latitude are the ones that go vertical. So this is called a latitude. No, I'm wrong. Which one was it? Yeah, so this is right, correct? So latitude is the almost the vertical one. Horizontal ones are longitude. Okay? So the one right in the center of the Earth, this one right in the middle, is called equator. Equator. You guys already know this, right? And the one prime meridian, where is this one? Prime meridian is the one that goes through England. This is England. So the one that goes through, the prime is chosen that way. So you could actually choose something going through like Ohio, the one Ohio. Okay, but prime one is this one in meridians or long in latitudes. The prime one is this guy. Should I pick a better color? Anyways, these are just the titles. We don't care. But why did they choose this prime? Because you need to start a 0 degree somewhere. This is where they start 0. If you go to the right of this 0, things increase like by 15 by 15, 15, 30, 45. Since you're going east this direction, it's 15 east. If you go to the west, the same distance, it's 15 west, 30 west, 45 west, 60 west. That's how they numbered these degrees measures, okay? Alright, so there is an east direction, west direction, and you can go up to 180 on each direction. Total is 360. Doesn't make sense because the full turn is 360. Same thing true for longitudes. Again, equator is 0 degree. Equator is 0 degree in longitude. If you go up, it's north. You go 15 by 15, and the maximum is 90. For longitudes, maximum is 90. 15, 30, 45, 60, and 90. For South is the same deal. Equator is 0, 15, 30, 45, 60, and 90. South pole is 90. North pole is 90 north, 90 north. Okay? Now what is the question here? Each city has its coordinates in terms of latitude and longitude, such as New York City is 40.7, so 40 north is about here, 40, okay, but it has a little bit change, so it's a little bit more than 40. And west 70 means you go 70 west from England, 15, 30, 45, 60, 70 somewhere here, and you meet those two and you get the location of the New York. Okay, so every city, even yourself, you right now from a satellite, you have a coordinate, right? Your coordinate is a little bit different than, because you're a little bit to the south and north, right? So everybody, I mean, in military they use this a lot. If you want to bomb a location, you give the coordinates, okay? So they find you on Earth, all right? So this is really useful, these degrees, because using these degrees, longitude and latitude amounts, you can measure the distance between 2 points, 2 locations, such as you can find the distance between Barrow, Alaska, and Kailua, Hawaii. A location in Hawaii and a location in Alaska, you can find the distance between them using a little bit of geometry, a little bit of degree measurements. How? So I'm going to find out Barrow first. Where is Barrow? In Alaska. So I'm going to assume it's somewhere here. So this is B, Barrow, in Alaska. And where is Hawaii? They didn't sketch it here, but it's about somewhere here, right? Am I right? No, a little up maybe. Hawaii is somewhere here. Okay, what's great about these two locations? This is Kailua, K. Okay, this is B. What's great about these two locations is they are almost, look at these amounts. They are almost on the same longitude, right? They're almost, Lucy, they're on the same longitude, look. Yeah, they're a little bit off, but we can say, I'm okay with that. It's a little bit off, but we can round it off being the same. So they're asking this distance, find this distance. Okay? Alright, here is the trick we need to do. Now, think of the center of the earth, inside in the core, lava. Where is it? Its center is here. Just think inside, dig into the earth, and this is the center of the earth. Extend 2 lines from this location and that location. I want to ask you this. How much is this angle between these 2 lines? What is this angle? Let's say theta. I'm asking you that. Anyone? How do you get it? At least don't tell me the result, but how do you get that angle between these 2 guys? Alright, hint, look at this. This is sitting at 71 degree. This is sitting at 19 degree. To measure this angle, this far, what do you need to do? You just need to subtract them. So the angular distance between these two is 71.3 minus 19.7. It has that many degrees distance between them. So which gives us almost 20, 51. What is that? 52.6. 51.6. So there is a 51.6 degree difference between these 2 points. So this angle measures 51.6. Okay, now going back to this question. How do you find the distance between 2 locations, Alaska and Hawaii, if this angle is 51.6? We know the degree, we just don't know radius yet. So again, here is the picture. 2 locations, angle is 51.6. All I need is the radius, so I can get this S. What is the radius? Because S is R times theta. How do I get radius? Right? Don't we all know the radius of the Earth, which is 3,960 meters? So the distance between Hawaii and Alaska is 3,960 times the angle 51.6. Right, this is in degrees. That's not acceptable. We need to change that into radian by multiplying that 51.6 with pi over 180. Now this is correct. And somebody needs a calculator, I think. And we need to approximate this into 5 decimal places. 3910 times 51.6 times 3960, thank you. 51.6 pi, and we divide all this by 180. That was it. Alright. 3,566. Is it 3,000 miles between Alaska and Hawaii? Yeah, it makes sense. Let me double check my numbers, Dottie. Yep, it seems right. 3,566 and up to 5 digits, right?
The 5 digits is because
oh, 5 digits.
Converts the radians before it multiplies the 2. And then it just asks for the nearest mile.
Yeah. It says, I didn't read this, intermediate calculations to 5 decimal places. So it says change these into 5 decimals and then round your answer to the nearest mile. But let's see if we do it later if it's gonna say incorrect. Maybe a slight difference between our results. But let's do, we already have a better calculator. Just round this into the nearest mile. 3,566 miles. But it may say incorrect because it says earlier compute this and get 5 decimal round off and then multiply. So in their answer there may be some big errors. Ours is a better answer though, better approximation because we have really good calculator here. But we did it later. If you do approximation later, you're always more accurate, but they don't want this accurate. Let's give it a try. 3,566. What did you get otherwise? Did you get? Yeah, it said correct. But what happens if you just get the approximation earlier, like pi over 80?
Got the same thing.
You got the same thing. You get up to 5 digits is 1, 2, 3, 5. 2, 3, 4, 5. If you take this and multiply by Earth radius now, no, 51.6, and then Earth radius, 3,960 was it? Yep. Look, I approximated pi over 180 into 5 digits, and then multiplying, we'll probably get, this is 66. We got 356633 earlier. This is 356566, but when you round this up, 3566, we end up with the, by luck, we end up get the right answer, okay? So this was my earlier answer. This was what I got, 35663. But if you do approximation earlier, you get 3565.6. So there is an error difference. But our calculations is more accurate in accurateness, but this is what they want. So go with approximating earlier, rounding off earlier, okay? Alright, we have one more question and we're all done with first section. There isn't much trick or high level theory in the first section. We learned here basically several basic formulas to compute arc length, area, degree measure, radian measure. Learn a lot of terminology, but more challenging parts will be coming up in the later sections. This is another formula. This time we are not computing just the length of the piece of the circle between two branches of the angle, but we are not computing length. This time we are computing the yellow area, this area. Like area of the pizza slice you have in your plate. How much is it? This is really interesting. How much area of pizza you ate. The formula is very similar. Arc length was r and theta. This is not just r and theta. You have a square around r, and you're also taking half of the result, 1 over 2. So you're putting 2, 1 on the denominator, 1 on the exponent, and that's it. Alright, let's do this. You're eating a cheesecake. This is your cheesecake slice. It's 12-inch in diameter and 20-degree angle. All we need is multiply them, right? 1 over 2, 12, and 20 is the angle. R is 12, 20 is the angle. I have two mistakes here.
12 is diameter and 20 is in radius.
Right, this is diameter, means 6-inch radius. This is 6-inch radius. So that's the first mistake. What is the second one you said? This should be in radians. So we need to fix this into pi over 180, which is gonna give us pi over 9. So A 1 over 2 36 pi over 9 is what we need to compute. That's 4. That's 2. Oh, that's 2 pi. That is 6.28 square feet. How much is our inch? Square inch. Square inch. 6 square inch area you ate. Okay? Round to the nearest tenth though. It says this is nearest 100, so 6.3 is the nearest tenth. What is this one? Its area is square, of course, inch square. Alright, this completes our first section. When you come back tomorrow, we are going to take a look at basic angles in a triangle, right triangle. We will learn about sine, cosine, tangent, cotangent, cosecant, cotangent, okay? That's all tomorrow.